So we can grab our fish geometry, let's Control C, we will create our Pyro chain or rather network over here to the side. Let's paste our fish geometry here so we can start working on the Pyro. And we will need to create our density source first, and we can do a simple scatter for this. So I will just scatter a bunch of points, turn off relax iterations. Let's increase the force total count until our meshes seem to be filled by points. So I'm again just gonna eyeball this value. And I think something like this will be fine. From here, we need to create a density attribute. So we want to generate some noise first. Let's do an attribute VOP. Let's rename this to set density. And we are kind of going to do the same operations that we did for our snow. Let's step inside. And instead of using the position as our source, we actually want to map it to our rest attribute. So this is why we created the rest attribute. Let's do a bind. Let's set the name here to rest, set this to 3 floats, and this is where I want to generate the turbulent noise. So let's drop our turbulent noise here and let's plug this in our CD to preview, and also we will do a fit range in between. And we also want to animate this, so let's just make this noise animate on the Y, and I will grab my time, do a vector or rather a float to vector. Let's plug this as our second value and plug this in our offset. Now I can right click and promote parameters, and also for our fit as well. So right click, create input parameters, and now we can go up. Let's set the noise type to simplex and just increase the frequency here. And as I change the frequency, I'm not getting the expected result, and this is because we have a small problem here. When we packed our geometry with the assemble node over here, in this assemble we chose to transfer the rest attribute, which means that it will look at the incoming geometry, so where we have the information for all of our points, it's going to transfer the average of this rest attribute to our single point, and then when we unpack it and we transfer back our rest, it's going to give us just the rest of one single point over here. So this was a mistake on my part, and inside this assemble node we have to get rid of this transfer attribute, so we don't have to transfer any attribute to the packed primitives because we are going to unpack everything later anyway. So inside this unpack node here, we don't have to specify to transfer this rest attribute because it's automatically given to us when we do the unpack it. So if we check, we can see that there is this rest attribute. But we do want to transfer the ID because this is something we didn't have on our geometry when we did the initial packing. All right, so to fix our problem, just make sure that you are not transferring the rest attribute. And if I go back now and check, we see that now we are getting the expected result when we adjust the frequency. So I can scale this back down and decide on some values that seem to be all right over here. So let's adjust the frequency slightly. And I might want to decrease the maximum value here and also decrease the minimum value as well. So we kind of normalize this noise, and maybe this will be fine. Let's check that this also animates. So we can see that the noise kind of swims upwards. And from here we can do our volume rasterize attributes, but we forgot to set the density attribute. So let's go back inside here and let's make sure that before our color we do a bind export and we create this density attribute. So I'm gonna go ahead and copy this, and I'll go up, go in my volume rasterize and paste the density here. And I will just link the particle scale. I'm just gonna eyeball this as well. Maybe 0.06 will be good, and let's start with a voxel size of 0.05 just to have enough resolution. And this looks about right. Let's plug this inside a Pyro solver so we can link the voxel size here. Let's set this to 0.05, and I will copy parameter and let's paste this in our voxel size for the volume rasterize. We will also need the velocity on our geometry. So if I go to the scattered points and turn on the vector display, we see that we don't have our velocity, and we probably need to transfer this as well in the unpack. So over here, let's also add our V. And if I go back and turn on the point display, we have the velocity for each point. And now because we have this velocity in our density volume rasterize, we can also turn on the velocity blur option here, and I will set this to a value of 1. Let's increase the samples and set the shutter offset to -1, so it smears backwards. And with this velocity information, I will duplicate this volume and I will use this to create a velocity field. So let's rename this to V, because the attribute that I want to rasterize with this is going to be the velocity, so V, and we can check that the volume name is also V. And for this, let's just rename this to density. And now we can merge these together. So we will merge both our volumes. And inside the Pyro solver, let's take a look at some of the settings here. We won't need to touch the bounds or collisions. Let's go to sourcing. We'll get rid of temperature and our burn. And we already have the velocity field here. So if I press play, we should see our smoke get this initial push that's coming from the movement of the geometry. Alright, so we end up with something like this. Just for now, I will set the voxel size to 0.1, just so we can preview this faster in our viewport. And for the final simulation, we will set this back to 0.05. And by default, the velocity is a little bit too strong for my taste, so I will go in the sourcing tab, and instead of add, I will use operation pool, just so we can blend this better over time. So I will turn on the direction strength, and I will give this an acceleration strength of 5. And now we should have the geometry influence the movement of the smoke, as we can see. So it's kind of following the fish a little bit, but it's definitely not as strong. So let's go back, and to make this feel a little bit more like it's underwater, we can slow down the simulation over time, and we can do this with a gas damp microsolver. So I will step inside here, I will drop down a gas damp, and I will link this in the advection output. And for the scale here, I increase this to a value of 0.15 just to add a little more. This is quite a sensitive value, so higher values than this will really slow down everything. And now if I play the simulation, we should get an initial push on our smoke from the velocity, and then it slows down over time until it almost stops. So we see that we slow down to a value of 0.1, which is essentially 10% of the initial speed. Okay, so this is pretty good. Let's go up, and I might want to, first of all, make the dissipation of the smoke slower. So let's go to the fields tab, and in the dissipation tab, we will reduce this to 0.05, and we are not using the flame field, so we can get rid of this.